Hello and welcome to another video. In this video we're going to be working on find the winner of an array game. And in this problem you're given an integer array R of distinct integers and an integer k, and a game will be played between the first two elements of an array, and the biggest number is the winner. So the winner stays at position 0 and the smaller integer moves to the end of the array. The game ends when an integer wins k consecutive rounds, and you want to return the integer that will win the game. Guaranteed there will be a winner and all the numbers will be unique. So let's kind of walk through this first example. So if we have 2, 1, 3, 5, 4, 6, 7, what's going to happen here is we can kind of simulate the actual game. So we're going to use a few variables to keep track of like the actual game. So we're going to have a winner variable. Let's actually move this down here so we have a little bit more space. Let's actually move it all the way down here. So we need k equals 2, so we need 2 wins. We'll have a winner variable that we're tracking, and then we'll have like a wins variable as well. So if we have a wins variable, it'll be 0 at the start, and we'll have like a current winner or something. And in the beginning, it'll be nothing. Okay, so we're going to compare these two. So 2 is going to be the winner here, right? So basically what they're saying is whatever the winner is, just take the other variable and move it to the end of the array. So we're actually going to not have this just so we can like easily move stuff to the end. So we're going to compare 2 and 1, and 2 is going to be the winner. So what we need to do is we need to take 1 and we need to move it to the end. So we're going to put 1 over here. Then we're going to say 2 is our current winner. I'll just write it in. So 2 is our current winner, and it just has 1 win, right? It won once. And we need to keep doing this until something has 2 wins. So we're going to compare these two now, and we're going to say, okay, well, 3 is the winner, and it's a new winner. It's not 2. So we're going to need to reset the win count. So if 3 is the winner, we're going to need to take 2, move it to the end, and change our current winner now to 3. So get rid of these. I wonder if I can... There we go. Okay, still can't do that, but whatever. So our current winner now is 3 with 1 win still, so we'll get rid of this. So now we're going to play again, and 5 is going to be the winner. So we're going to move 3 to the end. So we're going to move 3 to the end, and now our winner will be 5. And if we play one more time, 5 is the winner again, and so 5 gets the 2 wins it needs, and then you can break your loop and return. So essentially you can basically have like, the strategy would be something like make a deck, check for a winner, if new winner, reset wins, and then once something hits k wins, return that, right? So we just keep track of like a winner, and we return whenever we hit k wins, pretty much. And so this is very easy. You just write a deck, and you just pop left, push right, keep doing that. Now, obviously, let's say like you have something like this. Let's say this is 5 and this is 9. So if 9 is the winner, it's pretty easy to just pop 5 and have 9 as the winner. But what if we have this case, right? What if we have the case where we have 5 and 4? 5 is the winner, and we need to pop 4 and move it to the end, but we can't pop from the middle. So in that case, there's a bunch of things you could do, but one of the easiest things to do is just swap the values, right? So you could just say like, okay, well, 5 is the winner. If the 0 element is the winner, instead of the 1 element, just swap the values, and then keep going, right? So you just put the 5 here and the 4 here, and then you pop left and add to the end. And that's pretty much it with a deck. Now let's try to figure out a solution without a deck, just like some kind of intuitive solution that we have. So let's just have some more values. Maybe we can use these values actually. Let's say we have even something like this. And then we have, let's say we have like 9 here. And the k we're looking for is maybe, just say 8 or something, I don't know. Or actually, yeah, let's use k 8. This is kind of good. Okay. So let's say we have this array. We are looking for 8 wins. So what we're going to do now is we're going to do this without a deck. we're going to actually figure out a way how to do it basically in place without actually like moving stuff around. And it's not going to be too bad. It's going to be kind of similar process where you still do have this wins and cur and all these things. So let's declare these things again. So we'll have a wins and we'll have a cur. So we're actually going to set cur to the first element in the array. So we'll set it equal to 4, and I'll show you why. And we're going to set the wins to 0. Okay. And then we're going to be kind of doing the same thing, except now what we're going to do is we're just going to compare. We're going to keep track of an index. So we'll have an index, and that'll be, so essentially the index is going to be, it's going to start at 1. And I'll kind of explain why that is as well. So this is kind of like a nice setup. I tested this, and this is kind of like a nice setup of doing it. But essentially, what we're going to want, the reason we want to start at 1 is because we're going to be comparing our stored element to the element we're on. That way we could store 4 and compare it to 5. Because otherwise, if you start at 0, like what would you compare it to, right? I mean, I guess you can compare it to like the next element, but this kind of works out a little bit easier. So essentially what we're going to do is we're going to store our current element to the element we're on, and our current element is going to represent like our winner. It's going to be kind of the same, right? Our current winner. So we're going to say our current winner is 4 in the beginning with 0 wins, and then when we compare 4 to 5, if 4 is actually the winner, it will get a win, so it'll work out perfectly. Okay, so let's go through this. So we're going to start here, and 5 is the winner, right? So we're literally just comparing our current element to the element we're on. So 5 is going to be the winner. So we're going to update cur to be 5. I guess I'll just do this for now. And it will have 1 win. Now we will be on this element. We'll update our index as well to 2, right? So I'm actually not going to keep writing down the index. Essentially, the index will be like the arrow we're on. The index will just keep increasing by 1. And one small trick you're going to use is you're basically going to, like, let's say you get to this 9. The way you loop back to the front is you can just have your index be index equals index plus 1 mod the length of the array, right? So that way, let's say this array is length, what is it, 8. When you get to 7, then when you do this, you will be at 8 mod 8, which will be 0. So you'll kind of like loop around with your index. So what's going to happen here is here we're done with 5. Now we're going to compare 6 to our previous winner. 6 is better than our winner, so we will update cur to 6, and wins will be 1 because we have a new winner. Then we will go here. Then we will update cur to 7, and our wins will be 1 because we have a new winner. Okay, now this is where we start updating wins. So here we will see, okay, what is our old winner better than 1? Yes, it is. So we're going to keep the winner, and we're going to update the wins. So we'll update this to 2. Then we'll update it to 3, and we'll update it to 4, right? Because 7 is going to win over these. So our wins here, we can probably get rid of some of this. Okay, there we go. So our wins here will be 4. Now we get to 9. And 9 is better than cur, so we're going to update cur to be 9, right? We update it, and we're going to reset the wins. And now basically 9 is the biggest number in our array, so everything else we're going to compare to, 9 is going to win. So we were at 9, now we're going to loop back around to here. So we're going to compare 9 to 4, 9 will win, so we'll update the wins to 2, update the wins to 3. So 9 will basically win from here on in, so it'll be like 2, 3, 4, 5, 6, 7, 8, right? So then our thing will have 8 wins. And there we go. Now, one small thing, let's say K here, so this worked, right? Because 9 did have 8 wins, or actually, did it? Yeah, it did, because it beat 3, right? And then it beat, actually, did it? So let's see. So we have 1 win here, 2, 3, 4, 5, 6, 7, 8. Yeah, so it does. But let's say K is, there is like a few edge cases. Let's say K instead of 8 is like 100. What you can do is you can check for like, you can check if your current number is the same number that it was before. You don't want to add, you don't want to add a win. It'll actually work out either way. Like you can technically add a win, but essentially, right? Because when you compare 9 to 9, like it wouldn't make too much sense to give it a win, but it would still work out. But essentially what I'm getting at is if K is 100, no matter what this array is, we only need to make, like if this array is length 8, whatever our winner is only needs to win 7 times, right? because if it wins 7 times, that means it won over every single number in the array. So if it wins 7 times, like if it wins 7 times, that means it's going to keep winning. Like that means we found our biggest number. So essentially what we're going to do, and because in these dimensions, I didn't write it, but k is like 10 to the 9th. So what you want to do is you want to say minimize k to the minimum of k and length of the array minus 1. Because you're never going to have to do length array minus 1 wins. Like, if you get length array minus 1 wins, that means whatever element you pick is bigger than the rest of it. So it wouldn't really make sense to try to go for like a million wins here, because essentially if you're just comparing a number to other numbers and you're keeping track of the biggest number, once you loop through this array, once you have k wins, you're never gonna update your number, right? Like once you have your biggest number, it'll technically to get your biggest number, you only need to loop through your array like once, right? So and then you're just gonna keep updating wins for it. So essentially, I guess another maybe faster way of doing it, now that I'm thinking of it, it doesn't really matter too much, but I guess another faster way of doing it would be something like loop through your array once. If you found a winner with k, okay. Otherwise, your winner is guaranteed to be the biggest number that you found so far, right? So when we loop through this array, our current number is guaranteed to be the winner, right? Because we looped through the array once, we didn't find anything that matched k, so then whatever we have now is our biggest number in the array. So I guess we could optimize that a little bit, and we could do that in the code as well. It doesn't make too much of a deal, right? Essentially, if you don't do that, then you'll have some number, and then you're going to loop maybe another length of the array or something. So it's kind of like the same thing. But that's kind of like what it is. When you loop through your array, if you didn't find a number that only needed to win a few times, whatever you have now as your winner is never going to be replaced, because that's your biggest number so far, right? We're just keeping track of the biggest number we've seen. And then if it did win sometimes, now you're not always guaranteed to get the biggest number, right? Because like, let's say you only needed to win twice or something, then something else would win, like 7 would win, right? Because 7 would beat 6, and then 7 would beat 1. But if k is big enough, then that's kind of the case. So I guess we don't need to minimize k. What we can do is we can just say, like, if we didn't get anything through one loop of the array, then let's just say that whatever we have is our output. And so actually we're not going to minimize k, but you could do this as well. Like you could totally minimize k, and this would basically have the exact same runtime. But instead of minimizing k, we're just going to loop through the array one time. If we do find, we'll have a break condition, like if something does reach k, that'll be our answer. Otherwise, return whatever we have left at the end. Okay, so now we can code it up. So we'll say wins equals 0, cur equals array 0, I, the index we're on is 0, and we don't really need an index anymore, so we can just basically go through every element. So we can just say like for num in array, and so we don't really, actually I don't think we even need to keep track of an index anymore, because we're essentially just going to go through the elements. So we actually we do want to, so we're going to change this a little bit. We want to start with the first element, so I don't want to slice, because that'll create like another part of the array. So we'll just do like a for range loop or something. For I in range 1 length array is fine. Okay, so now basically we're going to say if the element is bigger than the old one, that's going to be our winner. And we do have our wins, and I think that should be everything we need actually. So let's see. So if array I is greater than cur, then we're going to reset our wins, and we're going to set cur equals to array I. And this is going to work because let's say we have an array like this, like 2, 1, 5. Even though we didn't go to this first element, because what's going to happen here is if 2 wins, we're just going to keep cur the same, but then we're going to increment the wins. So the way we're going to do it is like this. We're going to say cur here equals array I, and we're going to reset the wins. And so if the first element wins, then cur will still be that first element. We're going to reset the wins, and now regardless of what happens, we're going to increment the wins. And now we can just have a check if the wins is k, then we can return, right? So if wins is equal to k, then we can return cur here. Yeah. And now at the end of the loop, we should just be able to return whatever value we had in cur, because that's going to be, like, once we loop through our array, that's going to be guaranteed the biggest value. Okay, so let's take a look if we screw anything up. Seems reasonable. And there we go, and it's pretty efficient. So for the time complexity here, it's going to be O of n, because we're essentially looping through the array one time, right? And we don't need to, if k is too big, we don't really care, because once we loop through the array one time, we either have something that equals k that we returned early, or cur is the biggest number in our array, and that's guaranteed to be the answer. And for the space, it's going to be O of 1, because we realized we didn't need to use a queue. We can just figure out like what's the biggest number and just keep track of stuff. And yeah, so that's going to be all for this one. So hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.